dating technically can be applied everywhere. A number is a number.
I see.
Unless you put it in a context. Luminescence itself is serving as a tool for such things.
Good evening, sir.
Good evening.
But I would really like you to explain what you do or introduce in a more layman's language.
Okay, so basically I am Dr. Naveen Chauhan, working as an associate professor in physical research laboratory. I am heading a luminescence dating laboratory there. So basically luminescence dating is used for dating of the sediments. Okay, the concept is very simple. In the sediment, what happens, like we have minerals like quartz and feldspar. They have a tendency to store the energy. Where this energy is coming from? In the sediment, we have uranium, thorium, potassium, which is decaying with time. Okay, and since they are decaying by high energy radiation, alpha, beta, gamma radiation, they deposit these high energy radiation deposit their energy in the crystal. So as a function of time, these crystals keep on storing this energy, and when we release this energy, it comes in form of light, which we call luminescence. Okay, so that means as a function of time, energy is increasing. That means luminescence is increasing with the time. So if we know the amount of luminescence which is stored in the crystal, and we also know the amount of luminescence stored per year, we can estimate the age since when the crystal is storing the energy. The time since crystal is storing this energy.
So if you simplify for more archaeological part, how do you, in a more luminescence perspective, draw a relationship between the artifact and the sediment in that?
Yeah, so I am coming to that.
Yeah.
Basically, as I said, it stores energy as a function of time. Okay.
Yeah.
So what is the zero of this start? That is an important question.
Yeah.
Zero of start is when this luminescence signal is reset or energy starts building up.
Yeah.
And that storing of energy can be start at three events.
I see.
One is the crystallization. जब crystal अपने आप बनता है, when the crystal
is forming,
ठीक है, or form.
Yeah.
Second is when a crystal is heated to very high temperatures, say above 400 degrees Celsius.
So secondary energy consumption.
So it removes the electron or it removes the energy. Okay. And third is when this crystal is traveling through the light.
I see.
It is seeing the light. At that time also, this stored energy becomes zero. Now, when the energy gets zero and this crystal gets buried in the sediment again, it starts accumulating energy, and this is the time which we date.
I see.
Okay, so it dates the event of crystallization or the last burial or heating event.
So basically, someone is napping, or like our ancestors were napping, making stone tools.
Yes.
Or they're making pottery, and these potteries over a course of time they basically discarded.
Yes.
And they got buried.
They got buried in the sand.
Buried in the sediments, and basically we could tell the burial age of it.
That's it. So we are basically telling the burial age of your stone artifact, or the burial age of the pottery or the making of the pottery, you can say.
Yeah.
Because the age for which it is used is not that much. The time when it is made, at the almost within 10-15 years, it got buried. So that age we can estimate. Like you must have seen the Harappa pottery. Okay. So when the pottery was baked, it is heated up to 600 or above. That means that stored energy is gone, and we can estimate that age. So many of the Harappan sites were dated using luminescence dating technique. Similarly, when deserts were forming, sediments are being transported through air. Okay, when these sediments are transported, it is seeing the light, and when it gets buried, it starts accumulating energy, and we can tell when the sediment gets buried. That means we can tell when deserts start forming.
I see. So it can also help you to understand a lot of this climatic.
Obviously, it's always linked to the climatic feature.
Yeah.
Another thing is sediment is brought by the rivers. When the sediment is brought by the rivers, it is facing the light. And when it is getting buried, you can tell at what time the floods have happened, when the river has deposited the sediment, or as a function of time, how the climate has evolved, because every deposition stores a climatic signature.
Or even when did that river stopped flowing?
Yeah, same thing.
So just let me elaborate, or like let me rephrase what I would like to also ask. Like, so one of the question, so when we come to the cross-disciplinary research, is the accessibility,
yeah,
and the cost effectiveness. So dating and archaeology go hand in hand. We have mosaic of radiometric dating and now luminescence, various kind of luminescence-based datings are coming to picture. How accessible these methods are in terms of like protocol follow?
Now, basically, if you say there are two main contemporary techniques, one is carbon-14, another one is luminescence.
Sure.
Okay. Now, carbon-14 requires you to have a carbon in your sediment.
I see.
Okay, but like I said, in pottery you will not find the carbon.
Of course.
Sometimes in even the river or sand deposited by the air, aeolian sediments also, you don't find much carbon. In such cases, you can't date using carbon. So only technique which left is luminescence. And luminescence technique uses two minerals primarily, quartz and feldspar, which are available everywhere.
I see.
On the surface of Earth, or even in the solar system, some of the minerals are, so you can apply it to different planets, planetary bodies also. Moon, lunar meteorites, other places also you can use. So basically these two minerals are ubiquitous, and luminescence dating technically can be applied everywhere. Okay.
So if you have to talk about the chronological applicability of this.
Yes.
So we always have this, and we always tend to kind of, sometimes we undermine it. There's a number, there's a plus and minus, and there's an error.
Yeah.
So how fine the error goes when you go much closer to time, like in the younger phases, and how coarse, how does it behave in terms of luminescence?
Basically, luminescence has a very wide range of application.
I see.
The youngest sample which we have dated in our lab is around 6 years.
With the error margin of?
10% normally we say, but obviously for the younger sediment, it could get 20 or 15% also.
I see.
Because signal to noise ratio is poor.
Yeah.
Okay. But for older sample, we have dated 400,000 year sample in our lab.
Yes, sir.
And error margin is again 10% in that. And primarily on the daily routine, up to 100 kilo a year is very easily datable. For older age samples, we have to go into the research aspects, and we have to fine tune our techniques and apply multiple methods to probe the older ages. Obviously, when multiple methods are applied, error margin slightly increases, but at least something is better than nothing, because there is no other technique which is available in this range.
Like one thing that I also noticed following your work and your literary pieces, that we are always trying to reinforce the fact that what is the geological or lithological context, and that also is a very important aspect. As an archaeologist, we also try to very focus on a lot before we go into the archaeological interpretation. How does context matter for luminescence dating, and what are the limitations or challenges it can pose?
Actually, context is the most important, because a number is a number.
I see.
Unless you put it in a context.
I see.
If you just I give you the number, or you gave me a number, I will not be able to visualize what is going behind the scene to explain the science for it. If you are seeing it in a context, you will be able to say, after seeing the context, you will be able to predict, okay, before this is a number, and this number is because of a particular reason. If I don't know the reason, that means it can be anything. I don't know. So science need a logic, a reason for something to be there.
Because that is something. For example, like lot of we had a discussion about like many sites, human evolution sites, early like let's say early or middle Pleistocene, like from let's say 125,000 years and much upwards. They are sometimes found in a quartz gravel context, which basically can have a fine sediment that contain quartz, either primary to the deposit or the secondary to the deposit. And these factors matter because we are, at the end of the day, we are measuring the feldspar and quartz in those sediments.
Yes.
And the question comes then, how do you distinguish between the artifact that is embedded in the gravel and the sediment that came in that gravel that we are trying to measure?
Artifact, see, when I give you a luminescence age, I will give you the number.
I see.
Okay.
I see.
That number, according to me, means the last burial age.
I see.
So, if sediment is coming through light and getting deposited in near the artifact, and or artifact is getting buried, that simply means it's the age when it got deposited. It's not the age when it is formed. So only luminescence can give you the last burial age.
Agree with you.
Okay.
Like one thing you already raised about, like, so we are in a subtropical and tropical setting where organic preservation is a very big challenge.
Yeah.
In given that fact, we have a technique which is so powerful and which works, and it's applied. It has already transformed human origin research in subcontinent, but also archaeological research. Could you elaborate on that? Because if you see, after a certain point of time, there's a boom of dates that came from TL or OSL or post-IRSL. How this has transformed these aspects?
So basically, I will say it's the ease of applicability of technique and simplicity of instrumentation associated with.
I see.
Normally, the parallel technique like C14, obviously, as you said, that C14 requires the presence of C14 sediment. Okay. Even if C14 is present, then you need some sophisticated instrumentations to make it work. On the other hand, luminescence is a very quick technique compared to other things, and the instrumentation involved is not that much sophisticated. So in a way, it's like because the method is simple and ease of sampling is very good. You can just go and collect sample in a pipe. Anybody once learn it one time and he can bring sample easily. So it's like a very quick method. As a result, people started learning it quickly and seeing its potential, that the method can be applied to a variety of situations because of its ubiquitous nature. People are adopting it more and more nowadays. Another important thing is in like C14, there are some contexts like some inheritance problem, or you can say some contamination problem is there. At least in luminescence, we can avoid some part of contamination because it's based on the light bleachability. In case there is partial bleaching or sufficient light is not there, that signal is bleached fully, we have the method which takes care of these
like I want also. Like just a continuing question, and I think so you already answered it, but it would be really important to see in that sense. Like now we are moving towards the phase of cross-disciplinary or multidisciplinary research.
Yeah.
And from a scientific avenue of it, there are protocols. For example, let's say there are series of protocols. Some protocols are more intricate and complicated.
Yep.
Therefore, you really need a lot of fundamental and understanding to even have a grasp of it. Yes. I'm not saying being an expert, but have a grasp of it. Do you think this very simplified protocol aspects of luminescence make it more accessible for the or let's say archaeological community to come and be a participant of these procedures?
So basically, yes, you rightly said, there is a variety of protocols or methods which we use in luminescence. Some of the luminescence methods are very easy that even non-expert can learn in few months, and they are good to go with the technique. Although obviously to interpret the data or the analysis part, he has to do a bit of more involvement. However, with some efforts, he or she will be able to do the things. Other aspect which is really intricate, I will suggest a physicist is proper person to understand those things. Although right now many geologists are also equally capable who understand the technique well, and developing the new techniques also or new tools also using different type of signals. But still, I will say that yes, simplified part anybody can apply. So it is making things very convenient for the
people to some extent.
If you want to go for a higher version, then some expertise is needed.
So the marriage has to be there.
Yes.
At certain junction.
Yes.
Just to kind of wrap this thing, and I would like to ask two-part question. First, no, it's not a question, more of a curiosity that I have. There's some sample in more an archaeological context. that you analyzed, and it turned out to be like a very surprising result, and it's just like a more memorable sample that you analyzed from the archaeological context from India, that you could share the story of that?
There are some of the samples, but one of the sample, I say with the Anil sample, Devara sample only. When I saw the age of 247 for the first time, I got excited because I was not believing that. Then we repeatedly rechecked it several times and it was coming that number only. So then we were confident and we said, okay, let's go for it.
And that has a huge implication on global human origin research, and that's what makes it quite exciting.
Right.
Talking about excitement, as you mentioned multiple times over discourses and lectures, that luminescence technique has kind of advanced very rapidly over a course of year. What is the next stage for this advancement? What do you think things are going ahead?
Dating is now not a dating. It's used for studying the surface processes. Evolutionary surface processes. Earlier, different type of technique like trace element analysis or provenance studies were there by multiple methods. But luminescence itself is serving as a tool for such things.
I see.
To give you an example, one of the things where we can apply luminescence is how rapidly a mountain is uplifting. Okay,
like
we call it OSL thermochronology technique. As a function of height, the age of the sample is increasing because it has as a function of depth, there is a temperature gradient in the earth. At a particular temperature, luminescence signal get reset. And if the mountain is uplifting, that sample is uplifted, it crosses that temperature barrier. As a result, you get some age. And if you measure the two age differences and the height, you will be able to tell at what rate mountain is uplifting. Okay. Similarly, there is a tool which we call like luminescence sensitivity. Luminescence sensitivity means, see, two different provenances have two different luminescence signatures. Okay. If you are mixing these together and forming one system, okay, then you will be able to tell in what proportion they are mixing using these luminescence signatures. So, to give you an example, two rivers are bringing sediment from two different places. Okay, they are mixing and sending out the sediment. You don't know what is the quantity of the sediment or fraction of sediment this river is bringing or this. You can estimate these sediment fractions.
With
a very simple technique.
So basically, like, even if I try to put it in more archaeological scenario, that you have a river, and we always have river shifting in a deep time context. Sometimes river shifts because of tectonics.
Right.
And these things can be really, from the fine scale understanding, you can track it with the help of luminescence, as you mentioned.
In archaeological or historical context, you can say, sometimes people are saying like Yamunava and Chambal were together.
Yeah.
After means they were flowing separately, then they came together. You can take a profile as a function of depth, track the sensitivity, you can tell when the Yamuna mixed with the Chambal.
I think I really believe that will have a very huge implication for archaeology of that time period.
Similarly like hill slope processes you are saying. Hills are continuously eroding and river water is flowing. At what rate hills are contributing the sediment, you can estimate from here.
I see.
Just before the hills, you measure the sediment sensitivity. After the hills and sensitivity, you can estimate what fraction hill is contributing to the sediment.
Professor Chauhan, it's nothing less than an honor and I would say pleasure of mine to talk to you. To conclude this, if you have to say two lines to the emerging archaeological early career research fraternity, what will be in the regard of application and the usage of luminescence dating?
So, to the archaeological fraternity, I should say, like, many people means don't be scared.
I see.
It's although it's a physics-based technique, but it's a simple one also. Just use it as a tool, but don't use it as a blindfolded. Okay, use it as a tool. It will tell you when your system is getting activated or when a particular archaeological event happened, but place it in context. Without context, nothing
matters.
Yes.
Thank you so much. It's been lovely talking to you. Wish you a lovely evening.
Thank you.